Article 402 applies to the installation of wiring for lighting fixtures. Article 401 applies to electrical installations and conductors in general. Article 402, Section 402.12 states that fixture wires shall not be used as branch circuit conductors. This applies to both low voltage and line voltage fixtures. Therefore, low voltage fixtures must come equipped with a whip or have the wiring home run back to the transformer without a splice. If the wiring for a low voltage fixture is installed in conduit, it must comply with the requirements for wiring in conduit. Article 300.7 states that conductors used in conduit must be suitable for the voltage and temperature rating of the conductors. Article 334 covers the use of XHHW and RHW conductors. XHHW is a type of insulated wire that is rated for use in wet or dry locations. It is also heat resistant and flame retardant. RHW is a type of insulated wire that is rated for use in wet or dry locations. It is not heat resistant or flame retardant. Therefore, both XHHW and RHW conductors can be used in conduit for low voltage lighting fixtures. However, XHHW is a better choice for installations where the conductors may be exposed to heat or flame. To elaborate, the National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including specific requirements for low voltage lighting systems. Understanding these regulations is crucial for ensuring safety and compliance. When dealing with low voltage fixtures, a key concern is whether the fixture wiring can be used as branch circuit conductors. According to Article 402.12, fixture wires are not permitted to serve as branch circuit conductors. This restriction applies universally regardless of whether the fixture operates at low voltage or line voltage. In practical terms, this means that low voltage fixtures must either be pre-equipped with a whip, which is a short length of flexible conduit containing conductors, or the wiring must be run directly, or home run, back to the transformer without any intermediate splices. This ensures a continuous and protected electrical pathway. When installing the wiring for low voltage fixtures within conduit, compliance with specific requirements is mandatory. Article 300.7 stipulates that all conductors used within conduit must be suitable for both the voltage and the temperature conditions to which they will be exposed. The selection of appropriate conductors is vital for maintaining the integrity and safety of the electrical system. Among the conductor types commonly used in conduit installations are XHHW and RHW. XHHW, which stands for cross-linked polyethylene high heat resistant water resistant, is an insulated wire recognized for its versatility. It is suitable for use in both wet and dry environments and exhibits excellent heat resistance and flame retardant properties. These characteristics make XHHW a robust choice for a wide range of applications. RHW, which stands for rubber heat resistant water resistant, is another type of insulated wire approved for use in wet or dry locations. However, unlike XHHW, RHW is not specifically designed to be heat resistant or flame retardant. As a result, its application may be limited in environments where these factors are a concern. Both XHHW and RHW conductors are acceptable for use in conduit for low voltage lighting fixtures, provided they meet the specific requirements of the installation. However, XHHW is generally considered the preferred option, particularly in scenarios where the conductors may be exposed to elevated temperatures or potential flame hazards. Its superior heat resistance and flame retardant properties provide an added layer of safety and reliability. To further clarify, consider the scenario of installing low voltage landscape lighting. The fixtures, operating at 12 volts, are positioned throughout a garden and connected to a central transformer. Because fixture wires cannot be used as branch circuit conductors, each fixture must either have a pre-installed whip that connects to the main low voltage cable, or the wiring from the fixture must be run directly back to the transformer without any splices. If the wiring is run underground within conduit, XHHW conductors would be a suitable choice due to their moisture resistance and durability. In contrast, consider an indoor application such as low voltage track lighting in a commercial space. The track lighting fixtures, operating at 24 volts, are mounted on the ceiling and connected to a transformer located in a nearby electrical room. Again, fixture wires cannot be used as branch circuit conductors, so the wiring from each fixture must be run back to the transformer without splices. If the wiring is installed in conduit above the ceiling, either XHHW or RHW conductors could be used depending on the specific environmental conditions. However, XHHW would be the preferred choice if the ceiling space is prone to high temperatures. It is important to note that the NEC is a comprehensive document, and it is essential to consult the latest edition for the most up-to-date requirements. Local codes and regulations may also impose additional requirements that must be followed. Therefore, it is always recommended to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and standards. In summary, the NEC prohibits the use of fixture wires as branch circuit conductors for both low voltage and line voltage fixtures. Low voltage fixtures must be wired with a whip or home and back to the transformer without splices. When wiring is installed in conduit, conductors must be suitable for the voltage and temperature conditions. XHHW and RHW conductors are both acceptable for use in conduit for low voltage lighting fixtures, but XHHW is generally preferred for its superior heat resistance and flame retardant properties. Always consult the latest edition of the NEC and local codes for the most up-to-date requirements and consult with a qualified electrician to ensure compliance. Let's delve deeper into the specifics of these regulations to provide a more comprehensive understanding. The prohibition of using fixture wires as branch circuit conductors is rooted in safety considerations. Fixture wires are typically designed with a smaller gauge and lower insulation rating compared to branch circuit conductors. Using them as branch circuit conductors could lead to overheating, insulation failure, and potentially electrical fires. The requirement for low voltage fixtures to have a whip or home and wiring back to the transformer is intended to ensure a continuous and protected electrical path. Splices, if not properly made, can introduce points of weakness and potential failure. By eliminating splices, the risk of loose connections, corrosion, and other issues is minimized. When selecting conductors for conduit installations, it is crucial to consider the environmental conditions. Factors such as temperature, moisture, and exposure to chemicals can all affect the performance and lifespan of conductors. XHHW conductors are particularly well suited for harsh environments due to their robust insulation and resistance to moisture and heat. RHW conductors, while suitable for general use, may not be the best choice in demanding environments. The NEC provides detailed specifications for the ampacity or current carrying capacity of different conductor types. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature. It is essential to select conductors with an ampacity that is sufficient to handle the expected load. Overloading conductors can lead to overheating and potentially dangerous conditions. In addition to conductor type and ampacity, the NEC also addresses grounding and bonding requirements. Grounding is intended to provide a safe path for fault currents, while bonding is intended to equalize the electrical potential between different metal parts. Proper grounding and bonding are essential for preventing electrical shock hazards. The NEC also includes specific requirements for the installation of low-voltage lighting systems. These requirements cover topics such as transformer selection, overcurrent protection, and wiring methods. Adhering to these requirements is crucial for ensuring the safety and reliability of low-voltage lighting installations. It is important to remember that the NEC is not a static document. It is regularly updated to reflect advances in technology and changes in industry best practices. Therefore, it is essential to consult the latest edition of the NEC for the most up-to-date requirements. In addition to the NEC, local codes and regulations may also impose additional requirements. These local codes may be more stringent than the NEC in some areas. It is always recommended to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and standards. Let's consider some specific examples to illustrate these concepts. Imagine a scenario where a homeowner is installing low-voltage landscape lighting in their backyard. The homeowner plans to run the wiring underground in conduit to protect it from the elements. In this case, XHHW conductors would be an excellent choice due to their moisture resistance and durability. The homeowner would need to ensure that the conductors are properly sized for the expected load and that the grounding and bonding requirements are met. As another example, consider a commercial building that is installing low-voltage LED lighting in its offices. The wiring will be installed in conduit above the ceiling. In this case, either XHHW or RHW conductors could be used, depending on the specific environmental conditions. However, XHHW would be the preferred choice if the ceiling space is prone to high temperatures. The building owner would need to ensure that the wiring is installed in accordance with all applicable codes and standards and that a qualified electrician performs the work. It's also important to note the differences between Class 1, Class 2, and Class 3 low-voltage circuits as outlined in Chapter 7 of the NEC, specifically Article 725. Class 1 circuits operate up to 30 volts alternating current and 60 volts direct current and are subject to the general requirements for wiring methods outlined in Chapters 1 through 4 of the NEC. Class 2 and Class 3 circuits are limited in both voltage and current and are considered inherently safer. Class 2 circuits operate at a maximum of 30 volts alternating current and 60 volts direct current with power limitations based on voltage. Class 3 circuits can operate at higher voltages but have stricter current limitations. Because of the low risk associated with Class 2 and Class 3 circuits, the NEC permits the use of smaller gauge wiring and less stringent wiring methods. The specific requirements for Class 2 and Class 3 circuits are found in Article 725. In summary, when working with low-voltage lighting systems, it is essential to understand the relevant requirements of the NEC and local codes. These requirements cover topics such as conductor selection, wiring methods, grounding, bonding, and overcurrent protection. By adhering to these requirements, you can help ensure the safety and reliability of your electrical installations. And of course, never attempt any electrical work if you are not qualified to do so. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns. In the field, you might encounter situations that require careful interpretation of the code. For example, what if you're retrofitting an existing lighting system with low-voltage LED fixtures? The existing wiring might not be suitable for the new fixtures, or the wiring methods might not comply with current codes. In such cases, you'll need to carefully evaluate the existing installation and make any necessary upgrades to ensure compliance. Another common scenario is troubleshooting low-voltage lighting system. Problems such as flickering lights, dimming, or complete failure can be caused by a variety of factors, including loose connections, corroded terminals, and faulty transformers. A systematic approach to troubleshooting can help you quickly identify and resolve the problem. Always remember to disconnect the power before working on any electrical equipment, and use appropriate personal protective equipment, such as safety glasses and insulated gloves. Electrical safety should always be your top priority. The NEC is a living document that evolves to address new technologies and changing safety standards. Staying up to date with the latest edition of the code is essential for anyone working in the electrical industry. There are numerous resources available to help you stay informed, including training courses, seminars, and online forums. Take advantage of these resources to enhance your knowledge and skills. In conclusion, low-voltage lighting systems offer numerous benefits, including energy efficiency, design flexibility, and enhanced safety. However, it's important to understand the relevant codes and standards to ensure that these systems are installed and maintained properly. By following the guidelines outlined in the NEC and local codes, you can create safe, reliable, and energy-efficient lighting systems that meet the needs of your customers and clients. And remember, when in doubt, always consult with a qualified electrician or electrical inspector. The expertise and guidance of these professionals can help you navigate complex code requirements and ensure that your electrical work is done safely and correctly. Consider the scenario of installing a low-voltage lighting system in a swimming pool area. The NEC has specific requirements for electrical installations in and around swimming pools, including grounding, bonding, and the use of ground fault circuit interrupters, or GFCIs. These requirements are designed to protect swimmers from electrical shock hazards. The low-voltage lighting fixtures must be specifically designed for use in wet locations and must be properly grounded and bonded to the pool's grounding system. The transformer must be located at a safe distance from the pool and must be protected by a GFCI. The wiring must be installed in rigid metal conduit or electrical metallic tubing, or IMT, and must be properly sealed to prevent water from entering the conduit. Failure to comply with these requirements could result in serious injury or even death. As another example, consider the installation of low-voltage lighting in a hazardous location, such as a factory where flammable materials are present. The NEC has specific requirements for electrical equipment installed in hazardous locations, including the use of explosion-proof enclosures and intrinsically safe circuits. The low-voltage lighting fixtures must be specifically designed for use in hazardous locations and must be properly installed and maintained. The wiring must be installed in rigid metal conduit and must be properly sealed to prevent the ingress of flammable materials. Failure to comply with these requirements could result in an explosion or fire. Low-voltage lighting systems can also be used for control applications such as dimming and switching. These control systems typically use low-voltage wiring to communicate between the control devices and the lighting fixtures. The NEC has specific requirements for the installation of low-voltage control circuits, including the use of appropriate wiring methods and overcurrent protection. The control circuits must be properly isolated from the power circuits to prevent electrical shock hazards. In addition to the technical aspects of low-voltage lighting, it's also important to consider the aesthetic aspects. Low-voltage lighting can be used to create a variety of lighting effects such as accent lighting, task lighting, and ambient lighting. By carefully selecting the lighting fixtures and positioning them strategically, you can create a visually appealing and functional lighting design. The choice of lighting fixture should be based on the specific application and the desired lighting effect. For example, spotlights can be used to highlight specific objects or areas, while floodlights can be used to provide general illumination. The color temperature of the light can also affect the mood and atmosphere of the space. Warmer color temperatures, such as 2700 Kelvin, create a cozy and inviting atmosphere, while cooler color temperatures, such as 5000 Kelvin, create a more energetic and focused atmosphere. The use of low-voltage lighting can also contribute to energy savings. Low-voltage LED lighting fixtures are significantly more energy efficient than traditional incandescent or halogen fixtures. By switching to low-voltage LED lighting, you can reduce your energy consumption and lower your electricity bills. In addition, low-voltage lighting systems typically require smaller transformers and wiring, which can also contribute to cost savings. When designing a low-voltage lighting system, it's important to consider the overall energy efficiency and sustainability of the design. Choose energy-efficient lighting fixtures and use lighting controls to reduce energy consumption. Also, consider the environmental impact of the lighting fixtures and choose products that are made from sustainable materials and have a long lifespan. By incorporating these principles into your design, you can create a low-voltage lighting system that is both beautiful and environmentally responsible. Now consider a scenario where low-voltage lighting is being used in a retail store to highlight merchandise. The lighting needs to be flexible to allow for frequent changes in display layouts. In this case, track lighting would be a good option. Track lighting allows for easy adjustment of the position and direction of the lighting fixtures. The track can be mounted on the ceiling or wall, and the lighting fixtures can be easily attached and removed. The track lighting system must be properly grounded and bonded to the building's grounding system. The wiring must be installed in conduit and must be protected by an overcurrent device. The low-voltage transformer must be located in a safe and accessible location. The selection of lighting fixtures should be based on the type of merchandise being displayed and the desired lighting effect. Spotlights can be used to highlight specific items, while floodlights can be used to provide general illumination. The color temperature of the light should be chosen to enhance the appearance of the merchandise. For example, warm color temperatures can be used to make clothing look more appealing, while cooler color temperatures can be used to make jewelry sparkle. The use of low voltage lighting in a retail store can help to attract customers and increase sales. By creating a visually appealing and well-lit environment, you can enhance the shopping experience and encourage customers to make purchases.